Welcome everyone to today's webinar, and I'd like to thank you for taking time out of your very busy day to spend time with us. We're really excited and honored to bring the Remade Institute into our community for you to learn about the work that's happening there to accelerate the transition to a circular economy. So I myself only met Remade and the Remade folks a while back. In May, I was invited to participate in this year's peer review of the Remade Institute. The DOE invited me, and I was able to spend the better part of 3 days taking in presentation after presentation of projects in development funded by Remade towards the technology roadmap and the initiatives, again, to accelerate the circular economy. I was really stunned about the importance and the breadth of the work that was happening there, and really was excited to bring it to a broader community, into the LCA and building construction industry, where we spend a lot of time now ourselves. And what really got me excited was the work that they're doing to accelerate life cycle assessment tools, LCA data, and that really hits close to home for me, which is why I'm sure I was invited to participate as a peer reviewer this year. So the agenda is pretty straightforward. I'm going to do a quick introduction about sustainable mines, and then I'll turn it over to Nabil and Ed, and then there'll be plenty of time for questions. We will be able to send out the deck that you're going to see today. The webinar is getting recorded. There is a set of questions that you'll be presented when you leave the webinar that we're hoping you'll answer. Any questions that we don't answer on the webinar, we'll certainly respond back to you. You can leave any questions you didn't answer, and you'll certainly learn how to get more information about your own relationship with Remade through this presentation and afterwards as well. So it's really a very broad audience who is attending today. We've got people who know Remade and are attending because they're part of the Remade community already. We've got folks from the building construction industry who know about our transparency reports, know that we're a program operator, know about the transparency catalog. We also have people in higher education who use our very first product or tool, our Concept and LCA software, which for those of you who are in the building construction industry may not know that we even have this tool, this other tool that's a big part of our business, which is the thing that we created to found Sustainable Mines back in 2007. And so we are a cloud applications and services company. Our first tool, our Concept and LCA software tool, is designed to help manufacturers, any type of manufacturer of a physical product, to design greener products from the start. And when EPDs and transparency became a thing in the building construction industry, we expanded our thinking on the simplification and use of life cycle assessment in understanding product impacts and the way manufacturers can design to extend that to helping them market greener products by using the LCA information to tell meaningful stories to the marketplace, but also to make sure that they were driving the knowledge of their LCAs back into their product development processes so they could make higher performing products for which they could disclose that information in EPD. So our mission has never changed as a company. Our mission from day one has been to operationalize environmental performance into product development and manufacturing to drive revenue and growth through greener product innovation. So economies still need to grow, even though we're looking at reducing impacts and reducing waste and reducing consumption. So the only way forward is to grow our economy through higher performing solutions, products, materials that reduce the impact on the environment and still drive revenue and growth for those manufacturers. So, you know, our sights have always been set on teaching manufacturers how to use environmental performance as a innovation and growth driver. So teaching life cycle thinking or eco-design is where the innovation happens. LCA is just making sure that when you have new ideas, you're measuring to make sure those new ideas actually reduce the impacts or improve the environmental performance. Doing one without the other isn't comprehensive. You can think differently, but if you don't measure, you're going to have impacts. Or you could just measure without thinking differently, and then you're only going to have solutions that are minimally improved and not really transformative or providing exponential improvements, just incremental ones. And so when we launched our tool in 2009, there was very rapid adoption in higher education and in manufacturing, because those schools and those companies that were really looking forward to, for schools, creating knowledge workers for the greener product marketplace, and manufacturers understanding that where there's impacts, there's costs. Where there's costs, those can be mitigated. There's the opportunity for innovation. But really, you know, the market didn't really adopt a greener outlook overall, and it's taken many years for green or environmental performance to even be a mainstream concept. And, you know, unfortunately, human behavior is such that people don't change until it hurts. And so now things hurt and change needs to happen. And, you know, it's really exciting to have met the folks at Remade who are working on these really hard problems that need to get solved to drive change in the world. And we really had a meeting of the minds around creating tools. So our Concept and LCA software allows manufacturers to rapidly model product concepts and early stage design to make comparisons and make trade-off decisions. What we show is how to think differently, build models, understand the impact improvement or reduction, and be able to do that in real time. So I'm going to turn things over to the Remade folks now, and I think you'll see from the work that they're doing why I'm so excited about their work, and I think you will be as well. I'm just going to slip forward here, and Ed, I'm going to turn things over to you.
Okay. Okay.
All right, well, I will get started first, and then Ed will pick up from there.
Okay, can you all see my screen now?
Yes, we can all see it. Yep.
Okay, perfect. Okay. Go ahead, Nabil. Sorry.
All right. Sorry about that. So first, I want to say thank you so much, Terry. We're so glad that we got to know you through that peer review that for the Remade Institute, and we've been in touch since. There is a lot of exciting work that happens in sustainable mines, and it's very impressive to see organizations that really pushing the envelope in this area where we have a lot of common interest. So I'm just going to give you an overview of the Remade Institute and the vision for our work in this area, which is the first time actually in the US and as far as I know anywhere in the world that we're actually looking at the circular economy and sustainable manufacturing from a broad and system level, and ensuring that all of our work is guided by strategic directions coming from significant analysis to ensure that we're moving in the right direction. So next slide, Ed. Right, there's a delay here. Next slide.
I'm showing the next slide, and that's why I turned my
Okay.
video
I think
off.
there
Because
must be a delay there. Um, so just to talk about Remade and the vision for Remade and the mission of Remade. Remade is an institute that was created through a national competition in the U.S. by the government. We are a member of 16 institutes that are primarily developed to advance the U.S. interest in manufacturing areas, an area of high potential for the growth and impact on the manufacturing industry in the U.S. So we're a member of that 16 institute network. It is a consortium that is established by the government. Some of those institutes are funded by the Department of Defense. Some are funded by Department of Energy. Remade is one of them, and one that is funded by the Department of Commerce. The goal for Remade is to reduce embodied energy and carbon emissions through applied research and development. So we really are, the primary focus for us is in sustainable manufacturing and circular economy. The goals that we have is multiple goals. We're looking to develop transformational technologies to expand material recycling, material recovery, material reuse, and remanufacturing through advanced technologies, through innovation. If you take a look at the percentages that we have today that we're able to recover, it is definitely very low percentage, and the goal for Remade is to increase that percentage significantly over a period of time. We're also looking at reducing energy use, emissions, and by decreasing primary material use in energy-intensive industry. Also looking at replacing primary material feedstock with secondary materials, recycled materials. So by reduction of the primary material that is typically responsible for most of the emission and waste generation in manufacturing, we can make a huge dent in the footprint of manufacturing of materials. We're also looking at achieving better than cost and energy parity between secondary material, recycled material, and virgin materials. This way, making a lot of those recycled material more cost effective and more attractive for reuse by industry. And last, we're very interested in also workforce development. We're interested in making sure that a lot of this knowledge are disseminated and professionals in the field are up to speed with a lot of this stuff. We have significant goals in terms of in each one of those areas, and our objective is to make sure that we achieve those goals. The goals that you saw in the previous slide are 5-year goals, and the goal is the hope is that we achieve those in a very effective way during this period of time. The challenge that we have is that our system is more of a linear system. This is what we actually started with since the beginning of the Industrial Revolution. We call that the linear system, the take, make, and dispose. And our goal is really to look into ways to achieve that circular model where we actually, materials are recovered, we have a closed loop system, and we efficiently bring the material back to a form where it can be put back in use through many processes like remanufacturing and recycling, for example. The estimates for circular economy is that it would add $1 trillion for U.S. economy. The consumption of material, primary material, could be reduced by 32%, which is significant in terms of reducing climate change, greenhouse gas emission, and also the energy and waste generation from manufacturing of materials. The estimate is that for each 1,000 ton of material recycled, it creates 1 job. But really the biggest deal here is that many of those materials have a significant impact on the footprint of manufacturing. And through that work, we can actually make a big impact on reducing the the industrial footprint. Remade approach is focused on principles of the circular economy to adopt system level perspective. So the goal for us definitely is to ensure that we are looking at the picture from all its elements, not just the design, not just the recycling, and not just the use phase. We're looking at the entire picture to ensure that we're making strategic decisions. We're also very interested in reducing raw material consumption, and are also interested in making sure that we have innovation in the design approaches that allow us to achieve our goals and meeting all of those constraints. The preserve and extend, they're also one of the areas where we're very interested in extending the life cycle of system and product as long as possible, thus basically ensuring that we're reducing basically the use of new materials in the process, and also definitely a lot of interest in using waste as a resource, and through technology. You know, in our vocabulary, we don't use the word waste. We think everything is a resource in a different form, that if properly processed, it would achieve our goals. The goal for us is to develop innovative technology to recover, reuse, remanufacture, and recycle product, to focus on material classes, initially metals, plastic, fibers, and e-waste. This is the initial list of material which we are looking to expand as we move forward. And the goal again is to ensure that we train from the engineering level to the incumbent worker to also university level and technician level training, to offer all of those training to make sure that the workforce is prepared to address many of the challenges in this area. So as we looked at the Remade Institute with its focus, as I said, it's a national consortium, and we have academics, we have industry, we have affiliate members like trade associations, and we also have national labs. And in order for us to actually figure out how we can achieve our goals and make sure that our work is very strategic as we're looking at the metrics that we have, our national metrics, and ensuring that we're actually monitoring our progress and making sure we're moving in the right direction and addressing the right areas of focus. We have 5 nodes that describe the fundamental areas of work for us: the system analysis and integration, where we're constantly looking at the models and looking into material flows and look at the impact to ensure that to guide the work that we do in all other areas. We have a design for REX, which is focused on innovation and design and figuring out ways where we can intentionally design product that are optimized for the life cycle and for ensuring that we, for example, ensuring that the recyclability of material is more accessible than otherwise. We're also looking at manufacturing material optimization in terms of ensuring that the energy losses in manufacturing and the embedded energy in product, for example, is optimized, and the waste generation in manufacturing also is reduced. The other node is on remanufacturing and end-of-life reuse. This is where we look into product where remanufacturing can be very useful in capitalizing on the value embedded in product and components, and ensuring that we can actually take advantage of that and creating value for the user. Remanufacturing industry in the US is probably in the 80 billion a year industry and has significant growth, and it's in 12 different sectors, from aerospace to automotive to medical equipment and many other applications, and it provides significant value to the user as well as the manufacturer. Recycling is one of the largest area of focus, where we actually develop transformation technology in this area that allow us to bring material from the use phase and be able to bring it back to a form where it can be used again in new product. You know, again, I mentioned the classes of material that we're focusing on at our initial phase, which you know, again, will be growing going forward. Next slide. Next slide. So there must be a delay there, and oh, here it is. The education at workforce development is one of our major focus areas, because we believe that without educating the engineers, for example, on the challenges in recycling of certain material as they design a new product, it's probably very difficult for them to ensure that their design does not present challenges down the road. So having the right tools for technicians to make sure they can understand how to separate materials and how each process works, and also the people that at the factory level that also need to be aware of some of the new technologies and the tools that exist that can help them in their jobs. So we have so far we have 50 hours of online training. We have 14 online short courses. We do a lot of webinars, and a lot of those are recorded and available to our members. And we also have 3 certificate pathways that we continue to increase. And those are basically certificates that are that have multiple modules that allow people to become knowledgeable at different levels in a specific subject. So this way, it can help meeting the training needs for organizations. And again, we have found that those are extremely important, and some of the training that we offer is at the more at expert level, and some is at the introductory level, and some is at technician level. Now, just to give you an idea about how the Institute actually is, who are the member of the Institute, we have 130 members, 47% year-to-date growth. So we continue to expand significantly. 87% are engaged in the Institute activities, and we have 94% retention rate. You can see here we have 64 industry members, companies like Nike, Michelin, Unilever, Ford, and Caterpillar and John Deere. We have 31 academic institutions such as RIT, MIT, Georgia Tech, Illinois, Wisconsin, and many other great universities with significant capabilities in the topics of or the areas of focus of Remade. We have 29 affiliate members that includes 23 trade associations. And we also have 6 national labs like Argonne National Lab, Idaho National Lab, and Oak Ridge National Lab. So the format is definitely very collaborative, and ensure that we bring some of the greatest mind in the U.S. to address many of the challenges that we face in this area. Now, just to give you an example, for example, when we started, you know, we had a company, for example, that like Nike that works in footwear and many other you know, sports type products. And we also have a company like Michelin, and you know, that consortium model and the collaborative model that we developed, for example, through that we discovered that they do have some common interests, even though they come from different industry sectors. And through working with the university, they discovered basically, and with the institute, that they do have common interests in upcycling some of the rubber that used in their product. And that was a project actually that was conducted under Remade, and resulted in significant collaboration and value to all parties involved in this project. And that's one of the advantages of having a model like this, that allow for that collaboration and allow for the fundamental challenges that are some of this industry face to be addressed in a collaborative fashion. And as we tell our members, you know, the big issue is that we're addressing problem that no single company can address on its own, and there significant challenges can be addressed in a collaborative way can be addressed much, much better and much faster than if it's done by a single entity. And this kind of the broad overview of Remade, I hope it helps to give you broad understanding of the Remade and this concept. Now I'm going to turn it over to my colleague Ed Daniels, who can talk about more of the approach that we use in technology development, an example of the project that we're involved in. Ed?
Yeah, thanks. So I'm actually going to cover three things here this afternoon. So I'm going to go through this slide deck relatively quickly. As Terry said, the deck will be made available to you, but I want to chat a little bit about our technology development and then give you a few more details on our education and workforce development, and then finish up with a slide on membership and Remade. So the technology development portfolio, of course, we approach the full, all stages of the life cycle of a product, as Nabil mentioned. So we, of course, start with the design stage and work through remanufacturing as an alternative, recycling and recovery. We look at technologies to integrate recovered materials back into the manufacturing process through our materials manufacturing optimization. And the systems analysis portfolio really allows us to develop the tools that we need to identify opportunities in the marketplace and also to evaluate the potential of those opportunities. As of September 2021, we have actually launched about 61 projects. Based on those projects, we have 10 inventions that have come out of those projects so far, 38 publications. And one of the key things about Remade is that we evaluate the potential impact of our portfolio across a number of metrics that Nabil mentioned at the very beginning. These include embodied energy, where we want to reduce embodied energy. We want to decrease primary materials use and offset it with an increase in secondary materials use, and of course, decrease greenhouse gas emissions. So what you see inside each of the little circles there is based on the 61 projects that we have today, we are 90%, we've achieved 90% of the targets, 5-year targets that we actually have for embodied energy, about 2/3 of the target for materials efficiency, and almost all of the targets that we have for greenhouse gas emissions. So we do have a technology roadmap. It's available on our website. We update the technology roadmap each year to identify the high priority research activities. And I will just go through these briefly. So systems analysis and integration. Key focus areas are analysis methods, tools, and data, underlying data that allows us to evaluate the performance of our portfolio, techno-economic models, and also tools, again, to evaluate alternative technologies and the, how these technologies would actually impact the marketplace. Design for REX, again, incorporating considerations for end of life into the design stage is of course critical and can certainly help with ensuring the recyclability of materials as well as the remanufacturing capability of materials. We are looking at developing design for REX frameworks across a number of technology focus areas, and then design for REX tools, where we're actually looking at incorporating these tools into existing computer-aided design models. Manufacturing materials optimization is of course focused on trying to integrate recycled materials back into the manufacturing system. Key aspects are to characterize and qualify and develop simulation technologies that allow you to optimize the existing manufacturing operations for integration of secondary materials, and also to develop control technologies for existing manufacturing operations that would enable them to incorporate secondary materials, which are likely to have greater variability than, if you will, virgin materials. Remanufacturing, key components in remanufacturing are developing inspection techniques, analysis tools to determine residual value of end-of-life products, and then low-cost component repair technologies and restoration methods to bring remanufactured products back to a state where they can actually compete with like new products. Recycling and recovery, we're focused on technologies to increase the collection and recovery of materials. We're looking at mechanical recycling technologies, again, focused on the materials classes of interest to Remade. In the area of plastics recycling, we're also looking at chemical recycling technologies. And then finally on methods to characterize the composition of the waste stream and to develop techniques to neutralize the impact of residual contaminants on recovered materials. As I said before, we've released 5 RFPs to date. The RFP 5 just closed in July of this past year, and we are actually going through the review of those technologies. We've actually completed the review of those proposals. It's being reviewed by DOE at this point. We expect to be announcing the winners from that solicitation in the near future. We've allocated about $63 million to date on technology R&D projects out of a budget of about planned budget, 5-year budget of about $105 million. So there's still funding that's available. Just to give you a highlight on some of the technology areas that we're focused on, we're looking at films and flexible package recycling. Clearly, recycling of flexible packaging is a challenge, not only in terms of being able to recover those materials from a materials recovery facility, but also then in processing the materials because of the the fact that they are usually multi-layer packaging and they have contamination associated with them as from their use phase, which of course creates challenges on recycling those materials. 2 projects are representative of projects in this space. We're looking at a high shear catalyzed depolymerization, a multi-layer plastic packaging. Basically, this is an extrusion process that produces polymer precursors from multi-layer packaging. The second project is focused on actually recovering these materials from a materials recovery facility. And this is enhanced sorting and recovery of mixed flexible packaging at a materials recovery facility. I have a little bit more I can tell you about that project in a follow-up slide. Electronic waste is a key area. We generate about 7 million metric tons per year of electronic waste in the US, and only 15% of that's recycled to date, primarily because it's a relatively complex waste stream. So 2 projects that we're looking at there are chemical recycling to recover mixed plastics and valuable metals from e-waste using solvent-based processing. And another challenge with e-waste is, of course, the reverse logistics. It's a relatively dispersed resource compared to many other recycled materials. So some of the work that we're doing is looking at the logistics systems for collection, pre-processing, and production of secondary feedstocks from e-waste in order to optimize the logistics system, enhance the recovery of those materials. Paper and paperboard, of course, is a key area too. We presently dispose of more than 17 million metric tons per year of paper and paperboard. We actually collect a significant amount of paper and paperboard, but we export that material because we don't have the technology in the US that actually enables us to recover and recycle that material at a quality that we would need to meet our market requirements in the US. Two projects that we're looking at is a biological process. This is an enzymatic technology that would recover fibers and actually improve the quality of the recovered fiber to produce high value added paper grades. And then we're also looking at new approaches to remove the, if you will, the inks. These would be the not only the water-based inks, but also the organic inks that that are present on paper, recycled paper products. So, and those, of course, the inks, of course, need to be removed to enable that material to be recycled. Remanufacturing is a key activity. Nabil highlighted the importance of remanufacturing as an industry sector. But there are significant opportunities to increase the impact of remanufacturing by developing new technologies such as improving or remanufacturing of surface hardened steel components by using ultrasonic surface modification to if you will, repair those surfaces. A key area where we're trying to look at can we predict the performance of thermal sprays by just measuring the in-flight particle dynamics and then improve the actual performance of thermal spray repairs to minimize the reject rate that might otherwise occur during a thermal spray repair process. In polymer recycling and recovery, of course, is a critical area of interest in today's market, and we have projects that cover not only systems analysis and integration, but reprocessing, purification, chemical recycling of mixed materials, liberation, depolymerization, such as multi-layer packaging, cleaning to remove residual contaminants of recycled plastics. This would include things like milk, oil, food products, and then finally sorting, advanced sorting technologies. I just want to touch base on this one project. This is actually focused on recovering flexible packaging plastics wrap from a materials recovery facility. The project team includes the American Chemistry Council, Resource Recycling Systems. This project had a total funding from Remade at about $1 million. They're still, I'm going to say they're about 75% through the project. In this project, they actually looked at or integrated optical sortation systems, a series of them, into an existing MRF operation. They actually integrated it into their paper recovery line with the intention of pulling the flexible films, packaging film out of that paper recovery line. And the objective was to recover that film with a residual paper contamination of less than 8%, and then produce a bale that could be evaluated, plastic bale that could be evaluated for 3 different product markets. One would be to produce a construction material, actually a roofing material with compression molding, and then to produce pellets that might be used in other products, such as production of pallets, and then actually taking the pellets and then purifying the pellets to reproduce plastic packaging materials. They have completed the phase 1 of that project. They're actually in the phase now where they're starting to evaluate the market opportunities for the recovered products. Let me switch gears a little bit and talk about education and workforce development briefly. As Nabil mentioned, we do have an extensive EWD program with the intention of ensuring that the workforce is available and trained to implement the new technologies, such as those that are being developed by Remade, as well as other organizations to advance the circular economy. As Nabil mentioned, we have courses that certificate pathways where students or the incumbent workforce can actually receive certificates after they take a test after they have completed the courses that are offered. We offer these at the awareness level, the practitioner level, and the expert level. Currently, we have 3 tiered certificate pathways that are being offered. These include fundamentals of remanufacturing, fundamentals of mechanical recycling of plastics, and then the third one is emerging trends in plastics recycling, which covers chemical recycling, and then additional tiered certificate pathways are being developed. This is just a highlight of the first certificate that's being offered in emerging trends in plastics recycling. The total certificate would require a student, if you will, to take 5 short courses. Our courses are all taught by experts in the area. So in this particular one, the experts include Professors Grace Chen, Davida Masato, and then also Ron Rao, who are experts in their respective areas and provide a comprehensive set of courses for someone who wants to become familiar with trends in plastics recycling, and in particular chemical recycling. In addition to that, we also offer just individual short courses that are available through, actually they're available through our web to members of Remade. Some of the short courses that we've offered include flexible package plastic packaging. This is of course based on some of the work that I had previously discussed. Courses are offered by the principal investigators of our research projects, such as Dave Chenard from Michigan Tech and Meg Sokowitz-Klein from UMass Lowell. We also offer project webinars that are available on demand to our members. These, of course, outline the progress that is made on specific projects that have been conducted by the PIs, each of the PIs for our projects. So that summarizes EWD. I just have 2 slides on membership. So member resources. As a member of the Institute, you have access to an exclusive member portal. So through that, you have access to the on-demand learning modules that I previously mentioned. It gives you an opportunity to identify other members of Remade where you may be interested in perhaps developing a collaborative research project to assist you in project teaming. You have in the member portal, you also have detailed information on all of our projects. Actually, that 39 should now be 61. And in addition to that, you have also all of the publications and final reports for the current projects. So we are, because we are funded by the Department of Energy, we are ultimately required to publish our project final reports, but we have an agreement where we have a 6-month lead time before those are made publicly available. And during that 6 months, they're only available to members. Membership structure is we have 4 categories of membership that was previously outlined as Nabil mentioned: industry, academic, affiliate, national lab, and then for each of certainly for the industry and academic, we have a 3-tier structure for those for organizations who want to become members of Remade, and that structure has different price points and different levels of benefits. We do distinguish in terms of the annual fees for membership between small and medium sized companies versus large companies. The terms and conditions and agreement for all membership categories are consistent across the board. And membership is an annual basis with that can be initiated at any time during the year for a 1-year commitment, subject to renewal in subsequent years. So I think that covers everything that we want to talk about here today. I think most of the information that we've discussed, please visit our website at the Remade Institute. You can follow us on Twitter or LinkedIn. We have just released our 2020 impact report, which contains a lot of information about the research portfolio and the importance of that research portfolio. Our education and workforce development roadmap is available on the website, as is our technology R&D roadmap that I mentioned during this presentation today. So I think that concludes what we've got to say today, Terry, and we'll be happy to answer any questions.
Thank you, Ed and Nabil. Really, it's such an amazingly well-organized institution. I think because you covered so much content about what you guys create, I think there's some discussion about how the technologies get created that would be worth addressing. And so I'm going to kind of seed that discussion by starting with one of the questions. It came in early, and maybe some of it got resolved, but the question came in: does Remade fund any academic programs, as I see numerous academic partners? So I think if people can visualize this technology roadmap organized by these categories of solutions that need to be developed that Ed and Nabil covered early on, they've already thought through the problems that need to be solved, organized by problems and then technology tracks. So there's this very sophisticated matrix. The funding happens through the RFP process that is funded by the DOE, and every project application needs to get matching funding, either in kind or actual funding from an institution, a company, or an academic institution. And the RFP process involves primary investigators, the group who wants to do the project, looking at where the work needs to be done, because this framework already says, here's the problems we're solving, here's the technologies that need to be developed. Can you do something in that slot? And so the RFP process involves teams writing proposals about the technology they could develop to solve that particular part of the problem. And then that's what gets reviewed. And so the academic participation is very frequently, academic institutions are part of project teams. And that's how you see the affiliation of so many so many schools. But outside of that, Ed or Nabil, does Remade do any kind of academic funding outside of the RFP process?
Well, this is Nabil Nice. I think this is a really good question. The model that we have for funding is through the RFP process. So it's always have to be a competitive process. And typically our funding goes to the member of the institute, but also when we issue an RFP, people can apply even if they are not members, but they have to become members by the time they receive or they get the contract from Remade to start the project. The model is basically a lot of our work is really academic institution partner with industry, and as you can see, the largest number of members is from industry. So we do that matchmaking when we help academic institutions to partner with industry, and that help really ensure that the work is being guided by the potential user of the technology, and the work is calibrated by many people in the field to make sure the work is going to be valuable. So we fund basically projects that are, that typically for teams that consist of industry, academia, maybe national labs, or some of those. But everything has to go through the RFP process. There, definitely significant value in ensuring that this is done according to our roadmap, which identified the strategic priority for the institute, and making sure that there is a process for ensuring that we got the best options to address some of those issues. Ed, do you want to add anything?
No, I think that fairly well covers it, so I think as Nabil mentioned, everything does have to go through the RFP process, the solicitation process. We have a very rigorous peer review process that we go through to select and evaluate projects as a result of each one of our RFPs.
Yeah, and I think I would just like to add that just recently, for example, I don't know if it was 4 or 5 months ago, we had an RFP that was up to like $70 million. A few months after, we had one that was up to like $50 million, and we have one coming up hopefully in the couple of months. So we definitely are very active in trying to make sure that we identify, great transformational development opportunities that we can support that would help the industry. And again, we're very active in ensuring that we do that matchmaking for people from industry who have significant challenges to team them up with academics or national lab people from with the right expertise to address many of those challenges.
Yeah.
Right, so
Oh,
sorry, go ahead.
Yeah, just one other thing to add, because I see you've got this particular slide up, Terry, and that is that the topics that are the subject, any of the subject in our RFPs, typically come directly from our technology roadmap. So if any of you are interested in understanding what may be happening in the future at Remade with regard to future solicitations, the best source of that before the solicitation actually comes out is the information that's included in our technology roadmap.
Right. So this is what really impressed me initially is just how organized this vision of what needs to be done actually is. Because here, here's the matrix. So here's the 5 nodes horizontally, and then here are the categories of technology types or problems where solutions need to be developed. So you can see already the types of projects that have been funded and that are in development. And when the RFP process kicks in annually, they'll even kind of state the focus areas that they're really looking for solicitations where there's not as much work going on. So it's really exciting to see that if industry and academia, all work together, we'll be able to fill in this table to come up with the solutions to solve these challenges across the supply chain and the production processes. So it might be actually useful to talk even a little bit more about the training, because a lot of the folks on the call today work in organizations, manufacturing organizations, other educational institutions. So just to clarify, you have training online through the webinars that you've done publicly that's just available, anybody can watch. Is that correct?
Well, it is, I mean, the Institute is a consortium, so those are available for free to all of our members. We're working right now in making them available to anyone outside of the Institute as well, but there will be fee associated with that. But definitely we're trying to make sure that we expand basically the dissemination of all of these materials. Today, we haven't finished that yet, but today is available to the member of the Institute. And the membership is it's not that complicated. So we have different tiers. One tier will be for people who actually have limited role, and go all the way to the higher tier where people actually have access to IP and have the rights to IP.
But getting back to the workforce training, you have the webinars, you have the courses that have been developed, which by the way, get developed the same way through the RFP process. There's a description of the kinds of training that needs to be developed, and the solicitations with the RFP are from people who can develop those types of training modules. Can a member get custom training delivered to their organization?
Yeah, this is definitely a very good question. We have within our process, with the expansion of the work that we do and the know-how as well as the IP, we facilitate a lot of delivery for our members, including sometimes technical assistance, including assistance in developing their own strategic objectives and plans, addressing many of the R&D issues that we're involved in. It is definitely it's definitely an option for our members to ask for some customized training that we can do on site for a cohort group, or we can do also online, customize the certificates, for example, for a certain requirement from them. We haven't had any requests for that yet, but definitely those are things that can be done, and there are options for us.
That's great. Well, we are at the top of the hour, and I want to thank you, Nabil and Ed, for coming and sharing the work that you guys are doing. It's really important, and I would request those of you who are attending, as you leave, there are a couple questions we'd like if you had a moment to respond to, and it will also let you raise your hand if you'd like folks at Remade to either put you on their mailing list or get in touch with you to answer your questions. And so with that, Nabil and Ed, I'm going to thank you once again and wish everyone to have a great day.
Thank you very much for the invitation.
Sure thing. Bye-bye.